Welcome. This is a short tutorial on the K490 maps that the ScubaViz website puts out daily. And I want to give you a quick rundown of what these maps are and why they're special. First of all, to explain what I'm talking about, here's one of them. This is a custom map produced by ScubaViz.us server, and it has natural reefs, artificial reefs, depth lines, and the K490 NOAA value. This is a custom map that's produced by the Coastwatch software, and it's the K490 NOAA data. This data is provided by NOAA Coastwatch, and it's available publicly to everyone. Basically, the K490 image is looking at water attenuation, and that's the amount of light, or the amount of specifically the 490 wavelength light that is reflecting back to the satellite, and is measuring basically how blue the water is. To understand why that has relevance to diver visibility or water clarity in general, let me give you a little explanation. First of all, you have to understand that seawater absorbs different wavelengths at different rates. Your reds get absorbed first, and then your greens and blue are later. Blue light makes it all the way down to almost 200 meters. That's why they measure blue, because it's going the deepest, it can penetrate the most. So if your water looks more blue, then the light is penetrating further, and thus it's more clear. So here's another look at that. It goes through all the different wavelengths and why they're looking at this specific wavelength for water clarity, water visibility. This right here, this region, the upper 400s of the wavelengths, is the blues, and it penetrates all the way down almost 250 some meters. The greens and the purples are next, and of course the reds and oranges are the least. Those you lose pretty quick. So anyway, these the maps that we're looking at is just a measurement of the amount of light at that specific wavelength. So that's all it is. It's just a numerical value at each one of these 1 kilometer points, pixels, and it measures the value and displays it on this heat map. Now this heat map is an important feature to mention, because defaultly on their website, this is what you get. So this is done of a range of 6 to a 0.02. So that's the range this heat map is looking at. My maps that ScubaViz.viz server puts out are looking at a range of only 0.3 to 0.01. So it's a much less range, and there's a reason for that, and I'll get to that in a minute. But back to the light penetration to help explain that a little better. You have to understand that it's looking from a satellite. So it's not looking horizontally in the water, it's looking straight down. So you have to take into account the water column that's above the area that you're going to dive. Now, something that happens often in our area is this little strip here of basically a higher value. And I'm not 100% certain what causes this, but I do know that it correlates often to thermoclines. It also happens when you get some debris that comes up with the Gulf Stream, but it sometimes looks differently. The one that's typically related to the thermocline follows this drop-off point. So there's specifically this depth has some correlation to why this value is changing. Here's my theory. With a thermocline, the light's penetrating down, and in those particular areas, the water is so clear in the first 100 or so meters that it's actually picking up the dirtier water on the bottom. But as you move in closer to shore, the water is less clear closer to the surface, and so it actually makes it seem as if it's more clear. So this is just so clear on the surface that it's penetrating all the way down to the very bottom where it sees that dirtier thermocline. Whereas here, it's maybe only going half of the way down because it's already dirty, and it's giving you this value. So that's my theory as to why we're getting that. I'm not 100% sure, but I do know this little strip does relate to thermoclines. There's also another scenario where I've seen this, and that's where there's a dirty surface layer. So like in this picture, here's the bottom. It could be clear on the very bottom, or less dirty on the bottom, but then you have a dirty surface layer. And that sometimes happens when there's a swell coming in from the south, where it's coming over the Canaveral Shoal, and then it's causing turbidity to get swept up in the Gulf Stream. So you might have this area of turbidity. Or if you're diving in an area that's deeper, that is down current to an area that's shallower, so that there's turbidity getting produced on the shallow areas and then blowing over top of the deeper areas. So that's where you'd see this. This situation is more where you get the green water on the bottom and the light's penetrating down and seeing the green water on the bottom. So that's some minor details that might make a big difference if you're diving out here in these deeper waters. Typically, we'll see this in the summer, the summer thermocline that comes in. The easiest way to determine if that's what it is by observations out there. If we're getting observations of a thermocline, then it's easy to guess that this area is a thermocline that you're picking up and not surface turbidity. So that's why it's a great tool to get observations from divers as well as looking at the satellite imagery, because then you can correlate their observations back to the map. Next, I'd like to get into a little bit more of why our maps at scubaviz.us are special. This is a map that's publicly available on NOAA's website, and anybody can get to it. It's on the coastwatch.noaa.gov or eastcoast.coastwatch.noaa.gov. If you zoom in 500%, that's the most detail you're going to get for the Volusia coastline. Doesn't tell you a lot. And it's really difficult to even tell where the inlet is. So what I do is I use a tool that's available. It's called Coastwatch Data Analysis Tool. And there's a command line function that goes with it. And this tool enables me to add layers, like the natural reefs and the artificial reefs, as well as the land values that go with it. So there's the inlet, and so that definitely helps our divers and our observers of this map figure out where they are. But still, as you can see, this particular image, it doesn't have any detail. So part of what I have to do is, like we were doing on it before, is to adjust these margins, these values, to where the range is minimal. And there you go. So that's where our custom maps at scubaviz.us come in handy, is because we're looking at a limited range. Because anything above a 0.3 is going to be blacked out anyway, so it's irrelevant. And anything below a 0.01, the visibility is going to be so good, it's irrelevant. So we're only looking at the area only looking at the values that really make a difference. And that's why we use this value, and that's why this map is custom and produced in this fashion. So it's published, put out on our website. Looks like this. And this little red speckles, these are clouds and some errors that the computer system at NOAA incorrectly converted the clouds. So that's what you see when you see these little speckles. It's not actually dirty water. That's probably a cloud there as well. So with this information, if you look at it and you get an observation, say on Site 3, that visibility is 20 feet. Well, then you can presume that visibility maybe on Site 1 is likely close to 20 feet. Because they have, or was, because this is historical, the day before. The unfortunate thing is this is a day late and the visibility can change rapidly. But you can always look at the forecast and see if there's any major changes in the current or waves. And if there's not, then there's a high probability that the visibility is going to be similar than it was the day before. So I hope this gives everybody some better understanding of what these maps are used for, and let me know what you think. Remember, this is scubaviz.us. Like us on Facebook, and follow me on YouTube.